Hi, this is Alex from devstories.eu. LangChain v1.0 Orchestration Framework, Episode 7 of 20. Without memory, every interaction with your AI agent feels like a scene from 50 First Dates. The model starts completely blank, forgetting everything you discussed seconds ago. The solution is thread-level persistence. Large language models are entirely stateless. They process text and return text, retaining absolutely nothing between requests. To hold a conversation, an agent needs a way to store and retrieve past interactions. In the context of a single active session, we handle this through short-term memory, which is managed as part of the agent's state and persisted using checkpointers. People often think memory in AI is some internal model capability where the neural network magically remembers you. It is not. Memory is just message history. Thread-level persistence simply means taking the ongoing list of messages, saving it to a database after every step, and feeding it back into the prompt before the model sees the next input. The checkpointer manages this automatically, so you do not have to write the storage and retrieval logic manually. In LangGraph, state is saved per thread. A thread represents one continuous session. To enable this, you need a checkpointer. For development and testing, you can use the in-memory saver. When you compile your agent graph, you pass this saver object in as the checkpointer argument. This integration tells the agent that at the end of every node execution, it must snapshot its current state and hand it over to the saver. The state includes whatever you defined in your graph, which is typically a running list of messages. Let us look at a concrete scenario. You compile your agent with an in-memory saver. Now you want to invoke the agent. Instead of just passing a user message, you also pass a configuration object containing a specific thread ID. Let's use the string value conversation1. You send the message, "My name is Bob." The agent receives this, generates a polite greeting, and finishes. Behind the scenes, the checkpointer saves the updated state, which now contains the message stating your name is Bob, indexed under conversation1. Later, you invoke the agent a second time. You send a new message asking, "What is my name?" Crucially, you pass the exact same configuration object with the thread ID conversation1. Here's the key insight. Before the agent routes your new question to the model, the checkpointer intercepts the process. It looks up conversation1 in the in-memory saver, it retrieves the state snapshot from your previous turn, loads the saved message history, and appends your new question to the end. The language model receives the full historical context, sees the previous message where you introduced yourself, and successfully replies that your name is Bob. If you were to change the thread ID to conversation2 and ask for your name, the checkpointer would look for that new ID, find no existing state, and initialize a fresh, empty message list. The agent would have no idea who you are. The thread ID is the solitary key that binds a sequence of isolated stateless model calls into a coherent short-term memory session. The checkpointer abstracts away the repetitive work of managing message arrays and querying databases, guaranteeing that your agent can resume its work exactly where it left off, as long as you provide the right thread ID. Appreciate you listening. Catch you next time.